Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the reverse or doubly linked list. And for this particular challenge, we are using a Java 7 as our language to solve. If you want to use something else other than Java 7, then go ahead. I encourage you to do so. And for this particular challenge, given the pointer to the head node of a doubly linked list, reverse the order of the nodes in place, that is, change the next and previous pointers of the node so that the direction of the list is reversed, and then return a reference to the head node of the linked list. And the node right here, the head node might be null, that to indicate that the list is empty, so that we got one clue that we need to handle an edge case to check if the list, since the list is the name of the parameter of the data type of the doubly linked list node in a function of called reverse, and this one is the only parameter inside the reverse function, and the expected output is a public static of the doubly linked list node. So we are expecting either returning null or a doubly linked list node data type, and we need to check if the list right here is null, represented by the exclamation mark in front of the variable. If it is, then we need to return null as the answer, but it is showing that the parameter of the type doubly linked list, we cannot use the exclamation mark in front of this parameter name, and we can use another way around by using the list is equal to null, using the double equal sign or the equal operator to check if the list is equals to null. Then we need to return null instead. And sorry, we already covered the first thing from the node right here. And for the next one, for the function description, complete the reverse function, the data below, and we already describe this. And what about the input format? The first line contains an integer t, which is the number of the test cases. We don't know much about this part, but let's try to solve this one by one. And we have the constraint of the amount of the test cases, inclusive between 1 to 10 test cases, and the n itself, which is the denoting the element of the linked list, is either 0 from the edge case right here. If the number of nodes is 0 or null, it is 0 or inclusive to 1000 number of nodes, but it is doubly linked list node, so it going to be, they are all tied to each other using the next and previous property from the custom class layer here as our reference. And we have the doubly linked list node of the data, but we don't mind about the data, and the only thing that we mind is about operating the arrangement of the node from the order into the reverse order. Let's say this one is from the 1, 2, 3, and 4. We have node 1, node 2, node 3, and node 4. It is all denoting by the property of the data right here, of the integer data. Node 2, which is has the data property of 2, and then 3, 4. And we need to reverse this as the 4, which is placed on the bottom, and it's going to be reversed from the bottom to the up, so that is called the reverse. But since we are working with doubly linked list, we need to chain them to one to other within the sequence of its previous and the next property, so we have to not mess this up. Okay, so without further ado, let's solve this out. We already saw the explanation right here, so we already got the rough visualization of what we are trying to solve right here. The first thing we need to check is we can declare doubly linked list, since we are working with the Java doubly linked list node, and we can type this variable as the current and then equals to the list, that we take the list, and the current itself will act as the iterator, as the pointer to iterate over the node 1 right here, since head is only pointing to the 1 right here, and the list is not going to move anywhere, and we need to add something or some variable to somehow iterate over each node and checking for the value, and to check if it is already reaching the end of the node chain. and we can use the current list, and we already declare the current iterator right here, and then we need to check if it reaches the end of the node chain. If it is, then we need to mark the end of the node chain, and we can start from the back of the node chain and work our way up to the starting point from the initial parameter of the L list. And that way we can ultimately pointing to the last node up to the first node, so we can reverse the entire node chain. We can use the while loop while the current is not equals to null. Then we can use the current equals the current dot next. That way we are assigning the current to the next property, since one has the next property of the next property right here, pointing to the 2 right here. So let me visualize this is by creating node 1 and the next one, and we have the next end property. Property is denoted by the left angle brackets, and the right property is denoted, or the next property is denoted by the right angle brackets, and we're pointing to the 2, and we are pointing to the next of 3, and the last one is the node 4 itself, and the next one should be null, and the current iterator is pointing to the 1 right here by using the chevron sign or the caret sign with the C. That is the current, and that way after we use the while loop while checking if the current is not equals to null, then we can use current equals the current dot next. But the while loop, we can use the while loop to check if the current dot next is not equals to null. We can check for the next property. If it's not null, then we need to move the current to the current dot next. That way we are moving the current to the current dot next, which is the next property, which is the node 2 right here. And that way while loop will still runs, and it looks up for the current dot next if it is either equals to null or not. Then if it is null, then the while loop will stops, and if it's not null, then the while loop will continue to iterate like this and over time, and eventually it will reaches the end of the node chain. And the current dot next, checking the current dot next already equals to null, which points to the right arrow right here. Then the while loop will stops. The while loop will stops, and it's not going to process anything to the next iterator. But for this challenge, we need to check if the current is not equals to null. Checking if it's not null, then we need to move this to the next part. And that way we are moving to the next part, and the while loop will stop once it hits the current equals to null, and the current pointing to the null, and then it will not be processed again, and you don't have to worry about this part is going to be executed because the while clause is already stating as null. And not only that, we need to somehow record the data from the first to the last of the node chain, so that way we don't have to work 2 times, and that way will takes us much more time, or much more than intended time. And we need, at the same time, we also need to record the node after we traverse over the node chain right here. So that way, as we planting the reverse, answering the reverse mode of the output right here, we already got the previous iterations of the data, and so it is like hitting 2 birds with 1 stone as we iterate our current node. And we need to record this not just by creating an array, but we need something to declare some kind of stack, and that way we can use a stack like that revolving around the FIFO principle. What it means about FIFO is about first in, and first out, hence the name is stack. So let's say we are iterating over the current node of 1 right here. Let me move the current node to the 1 right here, and the while loop will runs, and that way we are storing 1 as our value to the stack. And the next one, while loop will check again to the next part, which is the node 2 right here, and that way we are inserting 2 at the top of the stack. So that is the FIFO principle, first in and first out. Maybe you still don't get the first in first out principle. And the next one, let's follow this tutorial instead. And next one, it's about the node 3. We inserting 3 on top of the both 2 and 1 respectively. And finally, we are inserting 4 at the top of the stack. 4 is placed above the both 3, 2 and 1. And next one, in order to get the reverse order like this, we need this first in first out principle right here from the stack. So that is why we are using this stack data type, or the operation method of the FIFO right here. And that way we are, since it is first in and first out, 4 is the latest one that we already inserted into our stack data type. Then 4 is going to be, as we use the method called the pop method, we are removing 4 from the stack, and that way we are returning 4 into our new node chain right here. And we remove 4. Then as we go through the next stack, which is the 3 right here, 3 will be eliminated and 3 will be returned as the new node chain as the output. 2 will also be removed, and also finally 1 is going to be removed from the stack. So that is the first in and first out principle. If the latest one is being inserted, then that latest one is going to be exported or popped from the stack. That is the order of the FIFO. Okay, so we need to declare our stack by declaring the stack using the capital alphabet or the capital letter stack with the data type of the integer. Why? Is because we are working with the data type of the integer right here, the data inside the node, remember that. And we call here, call the variable called the stack, and we declare a constructor called the new stack with the angle brackets, then the parentheses. That way we are constructing our new stack platform. And next one, we need to use the while loop, utilize this iteration of the while loop iteration to record our data from every node that we already iterate. We can use the Stack.push. Inside the push method, we can insert the data of the current node using the current dot, you guess it, data property. And that way we are storing all of the from the node traversal. And we already got 1, 2, 3 and 4 in a stack. And the next thing we need to do is about utilizing the stack data and process this as the output as the node right here. We can change this or construct this by declaring a new doubly linked list node called the dummy, and we can store a new dummy constructor, doubly linked list node called the dummy. Inside the node itself, we have to insert 0 or anything you want, because from the constructor right here, the class is not defining the constructor, but from this new doubly linked list node constructor right here, it only takes one parameter, I believe. We can insert 0 right here, and that way we got the node 0 with the previous value of null and the next property of null also null. They are both null because it is the only one from the constructor. And we don't have to worry about a dummy, but we can use the dummy as our new head. And next one, we need an iterator just like the current iterator for the list called the current. We can declare another iterator called the doubly linked list node of the dummy iterator called the iterator, and we can reference the dummy as our data type. And the iterator will work as the current node right here, the current variable, and we can construct with the iterator, construct our dummy node with the iterator with the help of the iterator. And next thing we need to do is using the while loop. While, since the stack data type right here has the method of isEmpty, then we can check, as long as the while loop, the stack is empty, isEmpty method, since is empty, we have the return either true or false. It is in a form of boolean. The isEmpty. Let me declare the isEmpty again. Yep, as you can see on the right side of the isEmpty helper linter right here, we have the boolean, so that is the output from the method either true or false, and we can declare an exclamation mark in front of it to check if the stack is not empty, denoting by the exclamation mark in front of the method. If it is, then we can use the pop to pop the value from the bottom to the top one, or from the last node of the chain to the next one, to the first one. Using the iterator dot next, we are assigning the next property of the current dummy right here. Since the dummy has the next property of null, then we can simply declare the next property of the 0 as the 4 right here, as 4, like this. We can declare a new constructor of the doubly linked list node, and we can assign the Stack.pop method. We can pass in that Stack.pop as our parameter of the doubly linked list node constructor, and Stack.pop will remove the 4 from the stack, and we only got 3 to 1 as the current state of the stack, and we return 4 as our new doubly linked list node constructor right here. And then we can declare iterator dot next dot previous. Why we should declare the dot next and then dot previous is because we already assigned the iterator dot next as our new doubly linked list node. Since new doubly linked list node is pointing like this, visualized like this, we have d4 because it is newly constructed, but we are assigning the iterator dot next. That way we are ultimately assigning d4 into our dummy of the current iteration. So we are chaining 4 with 0, but with the previous and the next property. Since 0 only pointed to the next property of 4, but 4 has not been pointing the previous property of 0, then we need to chain this with the previous to the back to the 0 is by using the iterator.next.previous. Since iterator.next, which is the 4 right here, because we already declare of the iterator.next, we already declare the constructor right here, and then we are pointing the previous, which is the left arrow sign right here. And you don't have to worry about getting confused because this is the visualization after we assigning this new constructor of the node. Pointing to the previous property, we can use the current iterator itself, which is the node 0, because the current iterator is pointing to the current dummy, which is the head of the 0. And the next thing we need to do, since the while loop will run as long as the stack is not empty, we can use the iterator equals iterator.next. That way we are moving our iterator from the just like the current part, since the state from the first while loop is running, denoted by the I with the chevron sign or the caret sign, and the next while loop will point to the 4 right here. It's because the stack is still not empty, because stack has the value of 3, 2, and then 1, and that way the iterator pointed to the iterator.next, which is points to the node 4 right here as the current iterator variable, and it's going to be processed again using the iterator.next, assigning the next property of the 3, and we have the new doubly linked list node Stack.pop. We are removing 3 from our stack. We have 2 and 1, and we are assigning 3, and then we are assigning the previous property of the 3 as the current iterator, which is pointing to the node 4 right here, and that way we are assigning the node 4 as the previous property of the node 3. That way we are chaining both 4 and 3 into our doubly linked list, hence the name doubly linked list node. And after all has been completed, then the last node should be 1 and the next property should be null. And the returning function or the returning statement, we can use the return. Instead of returning the whole dummy, which is 0, 4, 3, 2, and 1, we don't want the 0. We can omit the 0 by using the dummy.next. Remember, use dummy.next instead of iterator.next because iterator is already pointing to the latest one, which is on the right side of the iterator, like this. If we happen to use the iterator.next, it is possible to be null. The answer will be null. And the dummy.next right here, it is supposed to be the right answer because dummy, which is points to the head, which is 0 right here, dot next, which points to the 4 right here. So we only takes the portion of the 4, 3, 2, and 1 instead of 0. So that is why we are using the dot next property as our returning statement. So let's run the code to see if it works. And we have the illegal static declaration. It is fairly common in solving this type of HackerRank challenge. And let's look for the closing parenthesis right here. We have the on the line 108, since the closing brackets of the parenthesis is from the inside the class result, we are declaring the public static of the doubly linked list node inside of it. Then we can move this by using the alt and up arrow button to move the closing curly brackets of the result class. That way we are moving the public static of the reverse function that we are working right here outside of the result class. It is already highlighted as this square right here, and we can just submit our code again. So that's it. Thank you for watching the video. I hope you understand my explanation and everything. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Again, thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.